All right, in this podcast, we're going to look at calculating the Ecell for a galvanic cell. All right, so to determine the total amount of current or volts that are produced by a galvanic cell, you need to add the reduction potentials for both the balanced oxidation and reduction half reactions. This is a key word right here, people, so don't forget balanced. All right, so as an example, I'm going to keep bringing up the same old cell that we've been talking about. So we've been talking about this copper and zinc cell where copper is being reduced and zinc is being oxidized. Okay, so just a reminder, that's what we're looking at. All right, so when we first started, we are basically just given the information that we have this zinc copper galvanic cell, and then we pulled their reduction potential values from a reduction potential table. Because copper has the more positive value, we know this is going to be our reduction. Therefore, zinc is going to be our oxidation. So we need to flip the equation to make it oxidation, and we need to change our sign of our reduction potential for zinc. Okay, so now that we have our zinc flipped and the sign flipped, we can go on to determining our Ecell. Okay, so basically you're just going to add these values up. And when you do, you get that the total number of volts produced by this cell is 1.10 volts. Now, I want to point out that these reduction potential values are for 1 molar solutions of these at 25 degrees Celsius and 1 atmosphere. All right, so let's look at a few examples. So, example 1 wants to know the cell potential for a voltaic cell of nickel and copper. Wants the oxidized and reduced species and the half reactions and overall balanced redox equation. All right, and I pulled the reduction potential equations and reduction potential values out of the chart that you're given in this unit's packet. Okay, so looking at these values, the most positive one is going to be our reduction. So copper is definitely going to be our reduced species, and nickel is definitely going to be our oxidized species. Okay, so we're going to take our copper equation as is because it is being reduced and its value remains the same. And then we're going to take our nickel equation and we're going to flip it so that we get oxidation out of it, and then we have to flip the sign. So it goes from negative 0.25 to positive 0.25. Okay, so to get the cell potential, I'm going to add these numbers up. That negative goes with my electron. I kind of wrote those a little too close there. All right, but what we get here is we get 0.59 volts for our cell. Okay, now what I should have probably pointed out first is make sure that your electrons match. If they don't, you got to do some extra stuff. Okay, so that is our cell potential. Nickel is our oxidized, copper is our reduced. Got our half reactions already written. And then to write the overall redox equation, we cancel our electrons and add up our species, and there is our overall redox equation. Alrighty, in this example, we need to determine who is going to be oxidized and reduced between silver and nickel. So the most positive value is going to be the reduced. So definitely, dang it, thought my pen was working there. All right, so definitely Ag plus 1 electron is going to make our Ag solid with a 0.8 volts. So that's definitely my my reduced species here. All right, which means the nickel equation has to flip because that is going to be my oxidation. Okay, and because I flipped the equation, I need to flip a sign, so 0.25. Okay, now, of course, I need a charge balance here. So this is my oxidation half reaction. All right, and then I need to get my electrons balanced. So it's going to be a 2, 2, 2. All right, and then I can add them up to get my overall equation. So overall equation is 2Ag plus Ni makes Ni2 plus 2Ag. Okay, there's my overall equation. Already talked about what's been oxidized and reduced. Okay, now to our Ecells. Even though I multiplied this equation by 2 to balance out my electrons, my voltage does not get multiplied by 2, okay? You just never do that in a redox reaction. So my total voltage is going to be 1.05 volts. And there's my Ecell. Okay, last but not least, we have a galvanic cell with silver that is being reduced. So it's telling us straight out, hey, this guy's being reduced by an unknown metal. The cell potential is found to be 0.47, wants us to determine the reduction potential of the unknown metal. Okay, so I have silver's reduction potential and the equation for the reduction. So it tells us that silver is being reduced, so I don't have to do anything to that silver value. And I know that my unknown metal has some sort of value for its reduction potential. And the total of those two is 0.47 volts. Okay, so now if I just do a little bit of math here, a little bit of algebra, combine like terms, okay, and I get that X is equivalent to negative 0.33 volts. So that is the reduction potential for the unknown metal.